All right, good morning. We're working on 7.4 notes today. We're working with nth roots. How do we find them, what they are, and how we can manipulate them or use them? So our first problem here, we have the volume of a sphere can be found by using the formula V equals 4 over 3 pi r cubed. And they're asking us to find the radius of the sphere if the volume is 225 centimeters. So we know our volume is equal to 225 centimeters cubed. So if we just put this into our equation, and to find the radius, we're going to want to solve for r. So we have 225, that's our volume, is equal to 4 over 3 times pi r cubed. All right, so we're trying to solve for r. So the first thing we're going to do is multiply both sides by 3 over 4. This is going to cancel to 1 for over here. So 3/4 times 225 is going to give us 168.75 is equal to pi r cubed. Still trying to get that r alone, so we'll divide by pi. So once we divide 168.75 by pi, you can just place this into your calculator. You'll end up getting around 53.7, which is equal to our r cubed. And then to get our r alone, we'll take the cube root of r. So the cube root of 53.7 it is around 3.8. So that would be the radius of our sphere. All right, so moving on to other roots. All right, so we have our a squared is equal to 16. So basically, to solve for a, we're going to take the square root of both sides. So we have the square root of 16 is equal to 4. We say the square root of 16 is 4. 4 is our root. And if we're dealing with negatives under the root, we have the square root of negative 16. This is going to be no real solution. This is no real solution because we cannot have we can't have negative 4 times negative 4 is equal to negative 16. And 4 times 4 is not equal to negative 16, so there's no real solution. So if we look at our next power, we have a cubed is equal to 27. So to solve for a, we're going to take the cube root of both sides. And if we do that, so we have the cube root of 27 is equal to 3. And once again, the cube root of 27 is 3. 3 is our root. Right. Noticing we have the cube root of negative 27. We're actually this is equal to negative 3. Also another note, this 3 is known as our index. And why do we have a solution here? Well, negative 3 times negative 3 times negative 3 is going to give us our negative 27. So it has a solution. All right. Next, we have a to the fourth is equal to 81. So if we take the fourth root of both sides to solve for a, so we have the fourth root of 81, that's going to equal 3. Right. And over here we have the fourth root of negative 81. Once again, notice we don't have 4 numbers that multiply together the same number that equals negative 81. So we have 3 times 3 times 3 times 3. All positive numbers obviously going to equal a positive 81. And if these were all to be negative 3s, it would still be a positive 81. So there's no real solution here as well. All right, so we have a to the fifth is equal to 32. Solving for a, we take the fifth root of both sides. So we have the fifth root of 32 is equal to 2. Right. So the fifth root of 32 is 2. 2 is our root. Notice we have the fifth root of a negative 32 over here, and this is equal to negative 2. So if we have negative 2 times negative 2 times negative 2 times negative 2 times negative 2, we're going to get a negative 32, so that's why this is possible. So basically the general rule is we have a to the n is equal to b, and to solve for a, we're going to take the nth root of both sides as such, and we have the nth root of b is equal to a, and the nth root of negative b, it depends on whether or not the solution exists based on whether or not the index is even or odd. And if you notice above, if you notice a pattern above, you'll notice that every even index is actually, there's no real solution for a negative number under the radical. And for every odd index, there is a solution for a negative underneath the radical. So just keep that in mind when you're working with your radicals. All right, so if we simplify this, we have the square root of 25 times x to the fourth. Note that when there is no index, it's always going to be 2. So we have the square root of 25 times x to the fourth. And if you remember, we have the product property of our radicals, and we can actually split this apart to the square root of 25 times the square root of x to the fourth. We know the square root of 25 is equal to 5, and we have 4 x's here. So we have 1, 2, 3, 4. When dealing with the square root, we're looking for pairs of 2 to bring outside the radical, so we have 1 pair here. So we'll bring an x out, so we have 5 times x times the square root of x times x. Notice that we have 1 more pair of x's here, so we'll bring another x out in front. So we have 5 times x, and so this is going to give us 5x squared, and that's your answer. All right, so if we move on to our next example, also remember you can always pause the video if you need more time to write or to work on the problem or look at something. So if we look at number 2, we have the negative square root of y squared plus 2 to the 8th power. Once again, notice there's no index mentioned, so we know that that's a 2. So we're looking for pairs of 2. And if we look underneath our radical here, we have 8 pairs, or not 8 pairs, we have 8 of y squared plus 2. So if we want pairs of 2, we're going to have, we're not going to have this. We're going to have a negative y squared plus 2 to the 4th power. Because 8 divided by 2 is going to give us 4. So we know that there are 4 pairs. And so we brought 4 pairs out in front, and we still have that negative. So that's going to be your answer. All right, so if we look at our third example here, notice that our index is now 5. Now we're going to be looking for groups of 5 to bring out in front of our radical. So we have 32 x to the 15th, y to the 20th. So the first thing we want to do is break down this 32 so that we can find groups of 5 of some number to bring out. So we have 32, that's 4 times 8. We can break 4 down to 2 times 2. 8 we can break down to 2 times 4. Not all of these are prime yet, so we can break our 4 down into 2 times 2. We're trying to find the prime factorization of 32. All right, so we have the 5th root, and if we just write everything out, we have 1, 2, 3, 4, 5 2's. So 1, 2, 3, 4, 5. Then we have x to the 15th, y to the 20th. All right. So notice we want groups of 5, and we have one group of 5 2's. So we can bring a 2 out in front of the radical. So we have 2, and then we still have our x to the 15th, y to the 20th. All right, remember groups of 5, so if we have 15 over 5, that's equal to 3. So we have 3 groups of 5's for our x values. So if we bring 3 x's out in front, we have 2x cubed, square root of y to the 20th. And we'll do the same thing for our y value, or y variable. So we have 20 y's, so 20 divided by 5 is going to give us 4. So we have 4 groups of 5. So we'll bring 4 y's out in front. So we have 2x cubed, y to the 4th, and that's your answer. And then for our last example, we're looking for, notice that our index is a 2, and because our index is even, and we have a negative number underneath our radical, we know that we have no real solution. And it looks like that'll be our last example for today. We'll go through the rest of the notes in class tomorrow. Please remember to stop by Schoology and take your quiz, and have a nice day.